we still have 2 lessons, this lesson and one more. This lesson is called the relation between tangent of a circle. Okay, first, if I have here 2 tangents drawn at the ends of a diameter, we know that here this is a diameter of the circle, L is a line tangent and K is another tangent. Of course, we know that this angle is 90 and also this angle is 90. So very clear that the 2 tangents drawn at the 2 ends of the diameter are parallel. So if AB is a diameter and the 2 straight line L and K are 2 tangents to the circle at A and B, then the straight line L parallel to the straight line K. Okay, what about if I have here 2 tangents drawn at the 2 ends of the chord, not a diameter? If it is a diameter, so it will be right angle. What about if I have a chord and I have 2 tangents? Of course, these 2 tangents will not be parallel like this example. Here they will be intersecting at point, for example, C. Okay, so they're intersecting at point C. Now I will call AC and BC the tangent segments. They are called the 2 tangent segments. And this chord in which the tangent intersected is called the chord of tangency. Okay? Okay. I have here theorem for the 2 tangent segments. Where are the tangent segments? We have just said that these are the 2 tangent segments to a circle from a point outside it are equal in length. These 2 tangent segments which are drawn outside the circle are equal in length. Okay? There are 2 corollaries for the theorem. The first one said that the straight line passing, we have just said that AC here equal to AB because they are the 2 tangent segments that drawn to a circle from a point outside it. Okay? The straight line that passing through the center of the circle, this is the center, and there is a straight line passing through the center, and the intersection, this is the intersection point of the 2 tangent segments, passing through the center of the circle and the point of intersection of the 2 tangent is what? This line is an axe of symmetry of the chord of tangency. This is the chord of tangency. And these are the 2 tangent segments. The line that passed through the center and the point that intersect the 2 tangent segments. So this is an axe of symmetry. What does this mean, axe of symmetry? Axe of symmetry means it is a perpendicular bisector to the chord of tangency. So this will be 90 degree and it will bisect the chord if it is passed through the center and the point of intersection of the 2 tangent segments. Okay, what about the next corollary? Also in this corollary, the straight line passing through the center of the circle and the intersection point of 2 tangent. What does this line do? In the previous corollary, we said that if I have here drawn the chord of tangency, it bisect. It's an axe of symmetry. Means it bisected and perpendicular in it. Here, this line also bisect the angle of intersection and the angle that the angle between the 2 radii passing through the point of tangency. This is the point of tangency, and this is another point of tangency. And I draw the tangent from them. The radius that drawn from M to this point, not from M to another point, from M, the center to the point of tangency, and the center to the point of tangency. This line bisect the point, this angle, and also bisect angle A, which is the angle between the 2 tangent segments. Okay, so angle 1 equal angle 2, angle 3 equal angle 4. This remarks is the summary of the theorems and what we have just said and the corollaries, all of them in this diagram. First, AB equals AC because they are the 2 tangent segments. MB equal MC, 2 radii. BE equals EC and AM perpendicular on BC because this is an axe of symmetry. Measure ABM equals measure ACM because I know that tangent and a line from the center is perpendicular. Okay, and measure BAM, this angle equal to this angle, and this angle equal to this one, and also the angle, uh, uh, why this one is drawn here? Okay, and also measure angle MBE, this small one, and MCB, this two, equal to this one, and this two, which are equal to this one. Okay, this is summary for all what we have said. Let's see this drill. In each of the following figures, AB and AC are two tangent segments to the circle M. Find the value of the symbol used for measuring or in measuring. Here I have angle A50. I want first angle X. Okay, since AB and AC are two tangent segments, so they are equal in length. So this triangle is isosceles triangle. The measure of ACB equal ABC. So 180 minus 50 divided by 2, it will be 65. So angle X 65. Okay, and of course this angle 65. Then I want angle Y or angle Z. Okay, then this is radius and this is the tangent, so this is 90. So 90 minus 65, so this part will be 25. And these are MC and MB are two radii, so the small angle also will be 25. Or the same, this is 90 minus 65, this will be 25. 25 plus 25 equal 50, so angle Z will be 180 minus 50 equal 130. The second one, measure CAM equal 35, and I want X, Y, and Z. Okay, since AB and AC are two tangent segments, and this is a line from the center to the point of intersection of them, so bisect both angle M and angle A, so angle X will be 35. Since this angle is 90 and this one is 90, so this is a quadrilateral. 360 minus or 180 minus 70, so this will be 110, and MA bisect angle M, so each angle of them will be 55 degrees. Moving to the third one, here given that this side equal to this side, and don't forget that AB and AC are two tangent segments, so they are equal, so this triangle becomes an equilateral triangle, so each angle will be 60, and MA bisect angle A, so angle X will be 60 divided by 2 equals 30. Okay, what about angle Y? This is 90. Okay, and angle Y here equal 60. Sorry, angle Y equals 60 because you want ACB. Okay, what did you want else? You want angle Z. Okay, at this one 90, and this part we got it 60, so the small one here is this one is 30 degree, and of course this is 30 degree because two radii, so 30 and 30 60, so angle CMB will be 180 minus 60, it will be 120, so angle M here 120. Okay, what is the relation between angle, I will remove it, what is the relation between angle M, CMB, and angle CDB? Okay, they are inscribed angle and central angle subtended by the same arc CB, so the inscribed angle will be half the central angle, so angle Z will be half 120 equals 60. This is an example. In the opposite figure, XA and XB are two tangents to the circle at A and B. Measure AXB equals 70 and measure angle C equal 125. First, prove that BA bisect angle DAX. So I have here to get angle DAB and angle BAX. If they are equal, so BA bisect it. Okay, what can I get at the beginning? At the beginning, XB and XA are two tangent segments. So angle XBA will be equal to angle BAX, 180 minus 70, 110. So each part will be 55 degrees. This is 55 and this is 55. Now I want to get measure DAB. How can I get DAB? Okay, since ABCD is a cyclic quadrilateral, okay, because the four vertices lies on the circle, so each two opposite angles equal 180. So DAB will be 180 minus 125, it will be 55. So from here I will get that AB bisects angle DAX. Okay, then he wants me to prove that AD parallel to XB. AD parallel to XB. So if I want to prove parallelism, I must, maybe I have alternate angles, or equal alternate angles, or equal corresponding angles, or the sum of two interior angles equal 180. Where is letter Z here? Letter Z is XBA here. Do this angle equal to this one? Yes. I have just proved that this is 55, and I got this from the beginning. It's equal to angle BAX. It is also 55. So both of them are equal in measure alternate angle. So AD parallel to XB. Okay, this is another example. Let's see it. AB and AC are two tangent segments. When I see tangent segments, it means that they are equal in length. To circle M, B and C are at B and C. MAM intersect BC at point X. Y is the midpoint of the chord BD. Y is the midpoint of the chord BD. And XYM, this small angle, equals 35. I want to prove that XBYM is a cyclic quadrilateral. Cyclic quadrilateral, maybe two opposite angles equal 180. I have different things to prove it is a quadrilateral. Maybe the exterior angle equal to the opposite to its adjacent, opposite to the interior angle opposite to its adjacent. Okay, what I have here, these are equal. What else? I have Y is the midpoint and this line comes from the center, so this is 90 degrees. Excellent. I have this is a tangent segments and this is point A. There is a line between the center and the point of intersection of the tangent segments, so this will be perpendicular. What did you notice here? I noted that measure angle MXB plus measure angle MYB equal 180. So they are MXBY is a cyclic quadrilateral, okay, because the sum of the two is 180. Next, I want to prove that I want to find by proof measure angle A. Okay, here I couldn't prove it unless I will do here a construction, this one, to get another angle. From this construction, I found that measure angle what equal M, this is the only measure I have. What will be equal to MYX? Excellent, XBM. This is Y because this is a cyclic quadrilateral. I have just proved this a cyclic quadrilateral. Then these two angles are equal, common base MX. So this small angle equals 35 degree, this one. Okay, what I will do then? What will be next? What will be next? I'm giving you time to think. Okay, excellent. Since MB coming from the center, this is the radius, and this is tangent, so this angle equal what? MBA equal 90, right angle. And I have apart from the right angle 35, so the rest, XBA, will be 180, 90 minus 35, so this one, this green one, will be 55. Since they are equal in length, so angle ACB will be also 55, So I can get the third angle in the triangle A, which is 180 minus 55 plus 55 equals 70 degrees. This is a very easy drill. AB and AC are two tangent segments. Okay, so they are equal in length. AB parallel to CD. AB parallel to CD. I want to prove that CB bisect angle ACD. I want to prove that these are equal. Okay, first I have DMB equal 130, right? So can you get angle DAB? Yes, this is inscribed angle and this is central angle subtended by the same arc BD. So it is equal half the central. So this angle equals what? 130 divided by 2 equals 65 degree. Okay? Okay. And then this AB parallel to CD and CB is transversal. So angle DCB equal angle CBA alternate. Letter Z. So this angle equals 65 also. These two sides are equal length. I can get the other one. So it will be also 65 because this is triangle. So now both of them equal 65. So BC bisect angle DCA. Now it's so easy to get measure angle A. 180 minus 65 plus 65 equals 50 degrees. Okay, moving to another part of our lesson. Here I have definition that the inscribed circle of a polygon is the circle which touches all of its sides internally. So I couldn't say that the circle is inscribed circle of a polygon unless all the circle touches the sides of the polygon internally. So here M1, circle M1 is the inscribed circle of the triangle ABC, where the side AB touch the circle at D, side AC touch the circle at F, side CB touch the circle at E. And here also M2 inscribed circle of the quadrilateral because also it touch AB at Z and CB at L and CD at X, DA at Y. If the center of the inscribed circle of any triangle, this is inscribed circle of any triangle, is the point of intersection of what? This is point of intersection of the bisectors of the interior angles. What does this mean? This means that if I have a bisector here, bisector means it divided into two equal angles, and a bisector here, and a bisector for this angle. The point, the center of the circle which is inscribed inside the triangle, it is the same point of the point of intersection of the bisectors of the interior angles. So if this one angle equal to this angle, and this angle equal to this one, and this one equal to this one, they will, and when you draw them, they will intersect at a point. This point is the center of the circle inscribed inside the triangle. Okay, find the value of the symbol used in measuring. I want, first I want x, this is x centimeters, y centimeter, 12. I want AB. So AB will be equal to AC, angle side x. It will be 12 exactly. I want now y. This is right angle. Y is right angle, tangent, and the line from the center. So this is 90. So it becomes right angle the triangle by applying Pythagoras theorem. MA square will be 12 square plus 5 square. It will be 169 under square root. So y will be 13 centimeters. What about the next one? Okay, here I have AB and AC are tangents. AD is a tangent. So AB equal to AC. So AB equal to AC by applying an equation. 2x minus 3 equals 15. So 2x equals 15 plus 3 equals 18. So x equal 9 centimeters. X equal 9. Okay. Okay. What about y? Also AC equals to AD because they are tangent lines of the other circle. So also y minus 2 equals 15. So y will be 17. Okay. What about the last one? The last one, there is a small mistake here, or small given here, that this is not 6 centimeter. This small part AD is 2 centimeters. I want to get Y and X. First, since AD and AF are two tangent segments, so they are equal in length, so AF, this small part, is also 2 centimeters. So from this one I can get FC equal 5 minus 2 equal 3. So now I got Y. CF and CE also are two tangent segments for the same circle. Okay, because why? Because this circle is inscribed inside the triangle, so it touches it. So that's why they are tangents. So this is 3. So this side will be 3. And all of it is 7. So X will be 7 minus 4 equals 4 centimeters. Okay, this is very important. Before this one, okay, I have a part. There is a part missing here, but no problem, I can get it from okay, wait please just a minute. Okay, there is a part here. Don't know why it's moving like this. Okay, just a minute to get the page. Yes, this page. The common tangent of two circles. Okay, I couldn't draw here, sorry, in the PDF. So the common tangent, what is meant by common tangents of two circles? Common means it is a common between two circles, one tangent for two circles. There is a tangent called external or internal common tangent or external common tangent. It is said that the tangent, for example AB, is an internal common tangent to any two circles if the two circles M and N are, for example, are on two different sides of the tangents. Okay, so it is said that, okay, let's take it, I can take it to explain it. Okay, it said that the tangent AB is an internal tangent if I have here two circles, for example. Okay, and the two, if I have two circles like this one, two circles, and I draw a common tangent. If they are on the same side of the tangent, so it is called external common tangent. If they are on different sides, like when I draw like this, and I draw a tangent like this, for example, so this is a tangent, one circle on the right and the other circle on the left, so this is called internal common tangent. And these are the different situations or locations for the two circles and the common tangents. If I have two distant circles, I have L1, L2, L3 and L4. Okay, as you see here, you have for the distant circles 4 common tangents. So as you see, L1 is external or internal. Let's see the position of the circles with respect to the line. Are they on the same side of the line or the tangent, or on different sides? They are on the same side. M and N, and this is L, they are on the same side. So L1 is external common tangent. What about L2? L2 also, the two circles are on the same side, so it is called external common tangent. What about L3? As you see, L3, M is on the right of L and N is on the left, so they are on different sides of the common tangent, so this is internal common tangent. L4 the same. One of the circles is on the right, the other circle is on the left, so it is internal common tangent. What about if the two circles are touching externally? If I have L1 here, the two circles are on the same side, so they are external common tangent. It is external common tangent. L2, the two circles are on the same side, so it is also external. But L3, one of the circle is on the right, the other circle on the left, so it is internal common tangent. Okay, here L1, if the two circles are intersecting, so you will have, or you will find that you have two common tangents. L1, it's external because it is what? Because it is also the two circles are on the same side. And L2, external because it is on the same side. And there is no internal tangent for the two intersecting circles. If the two circles touching internally, so you'll have only one common tangent, because you cannot draw it here because it will be only tangent for the bigger circle. So this tangent, the two circles are on one side, so only one common tangent, which is external common tangent, and there is no internal tangents. If that one circle is inside the other, maybe it's concentric, maybe not, so there is no common tangents for these two positions of the two circles. The last drill I have today, in the opposite figure, AB is a common tangent to the circles M and N. As you see, MN, the line of centers equal 41, the radius of the bigger one, or the circle M, equals 17, and circle MN equals 8. Find the length of AB. Of course, I couldn't find it while it is without anything here. First, I will draw MA perpendicular on AB, NB perpendicular on the same, and I will draw N, any letter as you want, for example NX, parallel to AB, in order to help me to find AB, as if I'm dividing it into a triangle and a rectangle. Okay, since of course MA is a radius and AB is a tangent, this MA is a radius and A is a tangent, so as I draw here it is 90. And since NB is a radius and B is a tangent, so NB perpendicular on NA, so it will be also 90. Okay, and NX parallel to AB, measure AXN, because I draw it parallel, equal 90. So this figure NBAX is a rectangle. Okay, now I have what? I have BN equal 8, right? BN equal 8, because he told me that the radius of the small circle is 8. So similarly, XA, each two opposite sides in the rectangle are equal, so XA is 8 centimeter also. Till now I couldn't get AB. Can I get it from the rectangle up? Yes, this is right angle triangle. Very easy. MN is 41, MX very easy to get it because I know the radius of the bigger circle. He gave it to me 17, and I have a small part XA 8, so 17 minus 8, so MX will be 9 centimeters. By applying Pythagoras theorem, NX square will be MN square minus MX square, which is 41 square minus 9 square. It will give you 40 under root, it will be 40 centimeters, and AB will be equal to XN, because it is a rectangle, each two opposite sides are equal, so it is equal also 40 centimeters. Thank you, grade 9. See you inshallah next time and our last lesson in our curriculum. Thank you.